Hello everyone and welcome back to Chemistry Clarified. My name is Abbas Abdurrahman and today we are going to be talking about something very important and something that we deal with in our day-to-day activities, which is separation techniques. Now, before we go further in this video, I'm going to show you a practical demonstration of how separation technique work using the method of filtration. We are going to start with this simple experiment. This process is known as filtration process. If you don't know the meaning of filtration, don't worry yourself. So we are going to talk about it in details later in the video. So filtration, just know that filtration is a separation technique. Now, what are we separating? We have a sand sample here, a soil sample. We have it here. So we have an empty filter paper here that has nothing on it. We have a beaker, an empty beaker. So there's nothing inside, as you can see. We have a funnel here. We have a retort stand here. So, and we have a water sample here. So this is pure water. There's nothing has mixed with it. This is pure distilled water. Now, what are we trying to do? We are trying to create a mixture of this sand and water. And then when we mix the soil and the water together, we are trying to separate the sand from the water. So we are trying to separate the mixture through a process known as filtration. So to start with, we are going to pick up this blank filter paper and then we are going to fold it into four. As you can see, I'm going to give it the first fold. So this is the first fold. Then I'm going to give it the second fold. So this is the first step. Now, as you can see, this has been folded. It has been folded into four. So the next step is to insert this into the funnel. So I'm going to insert this filter paper that I've folded into four into the funnel and make sure that it is sitting inside the funnel. Now, the next thing is I'm going to mix the sand and the water together. So I'm simply going to do that by pouring the sand inside the water sample. So right now I've formed a mixture of soil and water. So let me stir it together. All right. So the next step is we are going to try to separate this particular mixture into its primary constituents, which is the water and the soil. So let's do that. Simply, we are just going to pour in this mixture of sand and water. We are going to pour that into this funnel with filter paper. So I'm going to be careful with it. As you can see water droplets. And that water droplet is clean. It is not coming out with the sand. So I can add more. Just a little bit more. So let's wait for the process to occur. Now I will speed up the video. Now that we cannot see any water dropping anymore, so we can see what we have got. Let's check the water first. As you can see, we started from cloudy water. You can see we are now left with a very clean water. So we have separated the water from the sand. And if we take a look inside the funnel with the filter paper, we are going to see the leftover sand. So the sand has been separated from the water. So that is separation techniques using the process of filtration. Welcome back. That is filtration in action. Now, what is separation technique? Whenever there is a mixture, that is, whenever we have something mixing with another thing, we can always separate it. Sometimes we need to separate those things to get something out purely. Like for instance, in nature, we have water mixed with salt in seawater. So sometimes we might need to separate that water from that salt. So we need separation techniques in order to achieve this. Now, what is this separation technique? Separation technique are the methods of separating the constituents of a mixture. Again, they are the methods of separating the constituents of a mixture. So, for instance, if you have salt mixing with water, you can use the separation technique method to separate that particular mixture. Now, this mixture, what is the meaning of a mixture? In chemistry, we say a mixture is a combination of two or more substances. Physically, that is, the two substances that are combining are only doing so physically. They are not combining in a chemical reaction. They are not undergoing a chemical change. Example, dissolving salt in water, as given here. Dissolving salt in water. Water is also known as H2O. Another example is mixing sand with water. Now, before we go further in this lesson, there are some key terminologies that we are going to be repeating a lot. So I would like us to quickly brush through them. The first one is a solute. We are going to be using the word solute a lot under separation technique. When they say something is a solute, it means it is something that dissolves. For instance, if you put salt in water, it is going to disappear. That is going to dissolve in that water. You will not see the salt again. It will mix with the water. It will form an homogeneous mixture with the water. Now, when this happens, the salt is the solute. The one that is dissolving in that thing is the solute. Now, to put it into definition, we can say a solute is a substance that dissolves in a liquid. That liquid is called the solvent. The liquid in which it dissolved in is called the solvent to form a solution. Now, this solvent, let's quickly divide it too. A solvent is a liquid that dissolves another substance, that is the solute, to form a solution. Remember, I told you the salt that is dissolving in the water is the solute. Now, the water itself that is dissolving that salt is the solvent. It is an example of a solvent. Now, when you mix both the solute, that is, for example, salt, and the water, which is a solvent, when you mix the solute and the solvent together, you are going to form something we call a solution. That is, when you mix salt, for instance, which is an example of a solute, with water, which is an example of a solvent, that mixture is what you can call a solution. Now, that will take us to the definition of a solution. And a solution is a homogeneous mixture. When they say a mixture is homogeneous, it simply means the mixture looks uniform. So the mixture is uniform. For instance, salt and water is an example of homogeneous mixture because it is uniform. And if you mix salt with water, you are going to have an homogeneous mixture. It is going to look uniform. And if you put a straw inside that particular salt and water, if you sip it from the below, from the bottom, it's going to taste the same as sipping it from the top. It will mix uniformly. The opposite is heterogeneous mixture. An example is sand and water. If you mix sand inside the water, the sand is going to come to the bottom and then the water will be at the top. They are not going to be regular. They are not going to be uniform. That's an heterogeneous mixture. But in this case, a solution must be homogeneous. Now, a solution is a homogeneous mixture consisting of a solute dissolved in a solvent. What we are just saying is that the solution must have a solute, for instance, salt again, and a solvent, for instance, water. So when you have two things, the solute and the solute is dissolved in the solvent, then you can call that particular mixture a solution. Now, this is what a solution is. A solute that has been added to a solvent, and then the solute has dissolved in the solvent, we are going to have a solution. Now, let's look at some types of separation techniques. In the beginning of this video, the experiment I showed you was using a type of separation technique known as filtration. This filtration can be used to separate insoluble solid from a liquid. What is the meaning of insoluble solid? Insoluble simply means a substance that does not dissolve. When something does not dissolve, it means it is insoluble. When it dissolves, it means it is soluble. So when they say something is insoluble, in chemistry, we are saying that thing does not dissolve. Now, an example is sand that doesn't dissolve in water. So if you have a mixture of sand and the sand, you know it does not dissolve in water and you want to separate it, a very good method you can use to separate it is to use filtration. And we are going to follow the procedure we did in the beginning of the video. That is, using a filter paper to separate it, and then the water that is dripping down of the filter paper, that water is called the filtrate, and then the residue, that is the sand, it is going to remain on your filter paper, and then you can now dry that sand on the filter paper, and you have successfully separated your sand from your water, and that is filtration. Now, the next type of separation technique is sieving. Now, sieving is always used to separate particles of different sizes. For instance, when you have rocks, small rocks, and then it is mixed with fine powders, if you have a sieve, the mesh of that sieve will only allow the fine powder to flow through, and then the small rocks are going to be left on the sieve. Now you have successfully separated the powder from the rocks using a sieve. And that method of separation techniques is called sieving. Now, the next one is sublimation. Now, before we talk about the separation type that is sublimation, let us first understand what sublimation is. If you have been following along and you watched our video on the nature of matter, we explained in details changes of matter. We are just going to summarize it here. Whenever you have something going directly from solid to gas, that process is called sublimation. And an example of something that does this is dry ice, which is CO2. Another example is iodine. Now, when you have something going from solid to liquid, that is melting. From liquid to solid, that is freezing or solidification. If a liquid is turning to gas, that is evaporation. If a gas is going back to liquid, that is condensation. But the key takeaway is that when you have a solid moving directly into gas, that is sublimation. And it does not pass through the liquid phase. That is, it doesn't melt first. So when there is an increase in temperature, it just starts to become gas without melting first. Now, that is sublimation. Now, when you have a substance that's sublime, for instance, dry ice, when you have a substance that's sublime and it is mixed with another substance that doesn't sublime, like chalk, what is going to happen? If you want to separate them, you can just increase the temperature, and the substance that does sublimation, that sublimes, is going to just sublime out of the mixture, and then you are going to be left with the one that doesn't sublime. In this example now, the dry ice is going to go out of the mixture because it's just going to turn directly from solid into gas, and then you'll be left with your chalk. That's how you can use sublimation as a method to separate a mixture. Now, the next one is magnetic separation, and this is used to separate a magnetic substance from a non-magnetic substance. What does this mean? There are some substances that are attracted to the magnet, like iron bar, for instance. It is attracted to the magnet. Now, if you chop some tiny pieces of iron bar and then you use it to form iron filings, now you mix that with sulfur powder, which is a material that doesn't get attracted to the magnet at all. You can easily separate that mixture by bringing a magnet near the mixture, and only the iron filings are going to be attracted to the magnet, leaving behind the sulfur powder. That way you have separated the mixture using magnetic separation. And the next one is decantation. Decantation is used to separate substances that does not dissolve in a particular liquid, that is, insoluble particles, from a liquid. For instance, if you have small rocks and then you have it inside the water, you can carefully pour out the water without letting the rock fall out, and that way you have separated the water from the rock. Although this is not a very efficient separation technique method, but still it is an example of a separation technique method. The next one is distillation. This distillation can be used to separate liquids from their impurities. Let me simply explain this. When you have water, it is always not pure because there are some dissolved minerals in it. So now, the kind of water that we use for experiments in the laboratory is called distilled water. And how is this distilled water made? They're using this separation technique to separate the water from all its impurities. So they are going to use this method to separate the water from its impurities. How are they going to do that? They are going to boil the water in a distiller, in a machine called a distiller. Now, all the water, when the water gets to its boiling point, it is going to turn into gas, from liquid water to gas. Now, when it has evaporated, there is a condenser. The distiller has a condenser, and what the condenser does is that it cools that thing, that water in gaseous form, it cools it down and turns it back into water. So when this happens, the water is going to be pure when it is collected back, and all the impurities are going to be left inside the distiller, because they are not going to evaporate with the water. So they are going to be left behind. Now you have separated the water from its impurities. Now, another thing you can use this method for is to separate two liquids that mix. Two liquids that mix. For instance, ethanol. Ethanol is an example of an alcohol, and this ethanol mixes perfectly with water. So now, when you have a mixture of ethanol and water, you can simply separate it by heating the mixture. When it gets to the boiling point of ethanol, ethanol is going to turn into a gaseous ethanol, and then you can condense it, cool it back until it becomes liquid ethanol. Now you will be left with water. So that's how you can use this distillation to separate your ethanol from water, which are two liquids that mix. And you can also use it to separate a liquid from its impurities. Now it is getting dark, and I'll postpone the next part of the video, which are other types of separation technique, to the next video. If you enjoy lessons like this, don't forget to like this video, share this video to your learning group, and subscribe to this channel. See you in the next video.